Most experience gravity as a simple downward pull, a weight keeping our feet on the ground. But in the early 20th century, Albert Einstein redefined that force. He showed that gravity operates as a geometric warping of space and time. Imagine the universe as a flexible grid. When enormous mass is packed into a single point, it bends this grid into a steep funnel. Despite myths, gravity follows predictable laws. If a black hole replaced our sun, Earth would safely continue its stable orbit. From far away, gravity depends only on mass and distance. The true danger of a black hole appears only when you approach its center. Because mass is concentrated into such a tiny region, you can get close enough for gravity to change violently across very short distances. To understand these objects, we have to leave the calm, flat stretches of ordinary space. We have to travel down into that steep gradient, where the familiar rules of reality simply stop working. You might expect the approach to be pitch black. Instead, the immediate environment around an actively feeding black hole is blindingly bright. Gas and dust settle into a flattened, turbulent disk that swirls inward at tremendous speeds. As this material spirals closer to the center, different layers crash and rub against each other. The sheer friction and compression heat the plasma to extreme temperatures, creating an accretion disk that shines fiercely, emitting intense radiation like X-rays. A rotating black hole drags the fabric of spacetime along with it, a process called frame dragging. This physical twist forces everything nearby to swirl in the same direction, like being caught in a whirlpool made of reality itself. This extreme curvature also distorts time, a phenomenon known as time dilation. If you were falling toward the black hole, a clock strapped to your wrist would appear to tick perfectly normally to you. But to someone watching you from a safe distance, your clock would look like it was ticking much slower. Here, space and time are no longer fixed, static backgrounds. They act as fluid, violent forces that actively dictate how matter behaves. The event horizon marks a strict geometric boundary in space. It represents the specific location where the laws of escape vanish, defining a threshold where the future points only inward. In this space-time map, curvature is so intense that direction breaks down. Every future path tips downward. Crossing depends on the observer. A falling astronaut feels no jolt, while a distant observer sees them freeze and fade into a red ghost. Inside the horizon, every path leads to the center, ending in what physicists call the singularity. According to the math, this is where the collapse continues until density and curvature become truly infinite. The singularity represents the absolute edge of our scientific map. It acts as a massive red flag in our equations, marking the exact spot where general relativity and quantum mechanics contradict one another, telling us that a deeper description of reality is still missing. Yet, for all their destructive reputation, these extreme objects are deeply woven into the larger story of the universe. They are active participants that shape their surrounding environments over billions of years. When two black holes spiral together and collide, they send out gravitational waves, literal ripples in spacetime. Using massive engineering facilities like LIGO, we can capture these incredibly subtle flexes in reality, allowing us to listen to invisible collisions happening billions of light years away. Through careful observation, astronomers have revealed a distinct pattern. A supermassive black hole sits at the center of almost every large galaxy, including our own Milky Way, anchoring the core structure. These central giants act as cosmic thermostats through a process called feedback. When they feed on surrounding material, they blast out tremendous energy as radiation and jets. This output heats up the surrounding gas across thousands of light years, suppressing the cooling required to form new stars. Black holes represent the ultimate cosmic paradox. They are mathematically simple engines defined by intense gravity and darkness, yet they serve as the fundamental anchors that regulate and organize the visible universe.